What's up, guys? It's Dr. J. Unmasked. No mask. Okay, I have a mask. It's right here, but I don't have to wear it because I'm outside. So look, right out in the parking lot behind the school where some of the teachers have their lunch. Some of us eat out here, okay? It's a nice spot. I like it. Fresh air. Feels great. Okay, so today we're talking about acceleration. And so that concept of acceleration builds upon what we've been learning. And so let's do a little bit of review, and then let's learn a little bit about acceleration in context, okay? I'm hoping not a context that you're going to experience, but it's a context, all right? So here we go. You'll see what I'm talking about in a second. So first, let's just hit the whiteboard and talk about some review here really quickly. So we'll have a common reference for some things we've discussed. Let me just blow up this whiteboard really quickly. All right, so today we're talking about acceleration. So acceleration. I get all these little window things out of my way. Okay, so today we're talking about acceleration, and I'm gonna hit a couple review terms before we get into acceleration itself. So the first thing I want us to think about before we talk about acceleration is velocity. Okay, velocity. All right, and so actually, yeah, that's fine. So velocity is distance traveled in a particular direction specific direction, okay, divided by time. Okay, the amount of time needed to travel that distance. And generally, when we talk about an object's velocity, we talk about its instantaneous velocity. So that means the rate of speed in a particular direction right now in one instance. So divided by a very, very small time interval. Okay, so velocity has this distance over time in a specific direction. Okay, so speed is just distance over time. Distance traveled over time. Velocity has this directional component, okay? So that's a very important term, right? Well, what's acceleration? So acceleration is defined as a change in velocity divided by time, right? The amount of time that is required for that change in velocity. Okay. So what's the context for these definitions, and why should we care, and how would we use them? So before we get into any further definitions or specifics or into any more like technical or conceptual information, let's just take a look at a real world situation in which having an understanding of velocity and acceleration would be helpful for understanding what's going on. Okay, so let's take a look. Let me open up a new window for us. All right, so here we go. Let's blow this up. All right, so here we've got a bike rider. Somebody's riding a bike. I don't know who, right? But this person is starting off right here, and the key thing is that this person throughout this video is going to pay a bunch of attention to their speedometer, right? So there's the speedometer right there. This person is going, I think this is kilometers per hour. So this person is going 34 kilometers per hour. So let's see how that goes. So the person starts off going 34 kilometers per hour. Let's see if that changes at all over time. So let's just watch this video, then we're going to back it up and talk about what's happening. Oh, and let me update the share so it'll optimize for video here. Okay, here we go. Drive along. Okay, let me see how fast I can go. All right, now I'm gonna focus on my speedometer because I want to watch my vehicle. let's watch that again. Okay, so let that be a tip for those of you who have yet to get their driver's licenses. All right, you want to watch the road, not the speedometer, while you are driving. Okay, set up a second camera to watch the speedometer so as not to wreck yourself. Okay, check yourself first, wreck yourself preferably never. All right, so this person got wrecked. And let's kind of talk about what's going on here. So let's watch through this video. So this person, okay, so now I'm going to define a reference point. So this exit from the traffic circle, I'm going to define as the starting point for this person's acceleration, this bike acceleration. And the starting velocity is 32 kilometers per second. Okay, so you start here. And where the person's going actually is all the way over here. So if you watch my mouse arrow, there's a bridge right there, okay, way down the way. I'm gonna call that about 200 meters away, all right? So the person's gonna go about 200 meters on the bike, starting at 32 kilometers per second, ending at about 32 kilometers per hour, ending at about 70 kilometers per hour velocity, okay? So that's how far this person's going, 200 meters. And the person's gonna pull that off in about 13 seconds. And it's what happens within those 13 seconds that makes all the difference. So notice the person starts here at 32 kilometers per second and is going to end at 70 kilometers per second. So there's an acceleration taking place, okay? And that acceleration is relatively constant over time. And so what we're gonna do is we're actually gonna graph this scenario in just a little bit. So let's go ahead and watch what happens. So now the person is not quite halfway there, but the person's going at 44 kilometers per hour. Let's keep going. Velocity has increased now to 55 kilometers per hour. Woot woot, now we're really going at 66 kilometers per hour. All right, moving along. And then, oh no, back down to 0 kilometers per hour. So we've actually had two big time acceleration events, okay? The first acceleration gets the person up to this high speed of about 70 kilometers per hour. The second acceleration is actually a negative acceleration or a deceleration that happens over about 20 yards here. So this person went about 180 meters and then actually had to decelerate over the last 20 meters because car, okay? So that actually decelerated over more like maybe like 7 meters because I don't see any serious deceleration until we get to about like this part maybe, or like right there. So that you can see the person's going 70. And then here, maybe the deceleration starts to kick in. Dear goodness. Oh no, right? So that's the situation. So what we're going to learn how to do today is how to graph one of those, or how to graphically represent what's happened here. Okay, so let's go ahead and calculate this person. Let's use these definitions here. So velocity and acceleration. Let's calculate this person's average velocity and average acceleration over that distance traveled. Okay, so I'm going to go ahead and clear all of this, and then we'll talk about those calculations. Okay, so average velocity, or sorry, average velocity. In fact, let's go ahead and graph this out first. So here's what happens. Okay, so this person. Let me go ahead and get this graph set up, and then we'll talk. Okay, so here we're going to be graphing a bike wreck. Okay, so we're going to need two axes. a distance axis and a time axis. Okay, so distance is vertical because distance basically depends on time, right? Over time, we're going farther and farther. We need more time to go a longer distance. Okay, so here's where we start, right? We start going at about 30 kilometers per hour, and then we increase our speed. So now per unit time, we're going farther and farther until, right, we hit the car. Okay, so pretty quick deceleration at the end. And I think this is a really good estimate. At the very end, we've gone 200 meters. And at the beginning, when we're just going to define our initial point at the traffic circle, okay, exiting the traffic circle, as 0 meters from that point, okay? And the overall time, if you watch the video, the amount of time it takes for the biker to go that far is roughly 14 seconds. So I'm going to go with 14 seconds. It might be more like 13 or 13 and a half, but I'm going to go with 14 seconds. Okay, 14 seconds. So, all right, so this person is accelerating. Oh my goodness, I got to stop, and then slamming on the brakes and hitting a car, right? Getting into an actual wreck. Okay, so that's how we can graph what's happening there. So let's go ahead and calculate. Let's calculate something. So we're gonna do a couple calculations. This is our first of 2 graphs, and our first calculation is going to be for average velocity. So I'm going to go ahead and calculate average velocity. So average velocity is calculated by dividing the total distance traveled by the amount of time, okay? The total amount of time of the trip, okay? And so if this biker had gone at a constant velocity, then that biker's distance versus time graph would look like what we see in red. But the biker didn't go at a constant velocity, okay? The biker went at an accelerating velocity, which is represented by the blue curve, an accelerating and then suddenly decelerating velocity. Okay, so represented by the blue curve, right? But had the biker gone at a constant velocity, you would see what you see on the red line, right? And so in order to calculate that average velocity, okay, the average velocity, again, which is represented by the red line, the slope of the red line, we have to divide distance by time. Okay, so how do we do that? So we go average velocity equals total distance, okay, divided by time, which equals 200 meters divided by 14 seconds, okay, which comes out to, if you do the division, you get 14.3 meters per second. Okay, so that's the average velocity of the bicycle of the biker on this trip. Okay, that ends in a wreck. All right, so that's a quick calculation. Go ahead and get that and this graph into your notes, and we'll talk about acceleration. All right, now we're going to pay attention to the biker's acceleration. So on the left side of our graph, we have velocity. Okay, and that velocity is in kilometers per second. So I'll go ahead and put the unit. Sorry, not kilometers per second, but kilometers per hour. And the biker starts at 32 kilometers per hour. And the highest velocity that the biker reaches is 70 kilometers per hour. And that particular acceleration takes place over 13 seconds, and it's roughly constant, okay? So here's our acceleration, all right? And in order to find here's our curve that describes this increase in velocity. So this is our velocity versus time graph. And so in order to find the acceleration, we actually need the slope of the line. Okay, so how do we find that, right? So acceleration equals change in velocity divided by time, which equals 70 minus 32. And our unit is kilometers per hour, okay, divided by 13 seconds. All right, and so that's going to give us, let me go ahead and do that calculation really quickly. That's going to give us 2.9 kilometers per hour. Okay, kilometers per hour per second. Okay, that's actually, it's velocity over time. So that's our unit of acceleration, 2.9 kilometers per hour per second. Okay, so every second, what that means is that every second, this bike is going faster and faster by 2.9 kilometers per hour. So its velocity is increasing by 2.9 kilometers per hour every second until right, the tremendous slowdown happens. So we're going to graph that in just a second. Okay, so let's look at the very last part of that bike wreck to see how acceleration played a role. So this person was going at the beginning, right? That person was going at 70 kilometers per hour. Okay, 70 kilometers per hour. But in the span of just 1 second, okay, that person's velocity went to 0. So that's a really violent event, right? That's sudden acceleration or sudden deceleration, right? That happened like this, okay? So that person's acceleration is the change in velocity, right? So it's final velocity, which is 0 kilometers per second minus 70 kilometers per second, or sorry, kilometers per hour. Okay, so 0 kilometers per hour minus 70 kilometers per hour, all divided by 1 second. So if you do the math, that's just negative 70 kilometers per hour, okay, per second. So that's really sudden deceleration, okay? The negative symbol there lets us know that the biker is slowing down. Really sudden deceleration, right? So everything that happened in that video can be represented and described mathematically by the terms that we're learning, both in our textbook and then of course here in this lecture, okay? So these terms that we use as scientists and physical scientists and physicists are super useful, all right? And we can apply them to really any situation that involves motion, okay? So what's up next, or what are we gonna be talking about next? Well, let me tell you. Okay, let me give you a little hint. What's up next involves one of these guys, okay? So more fun with motion and golf balls coming up. Between now and then, please take a picture of your notes and turn them in, okay? And as always, may all the forces be with you. And try not to let this happen to you. I am moving. Yep, that's not it. That is not it. That's not it. Stay safe.